Today's lesson is on graphing linear inequalities. If you take a look at the target, I can graph and shade linear inequalities. That means we're going to be graphing lines as well as shading half of the plane. And then I can model real-world problems using linear equations and inequalities. So we're going to continue working on those word problems that we've been talking about. Okay, the first sentence says here, what does an inequality represent and how many answers are there? So if you think about an inequality like x is less than 5, well, how many answers are there? Well, hopefully you understand that with x is less than 5, there are an infinite number of answers. And so we don't just draw the line, we actually shade the half of the plane because all those numbers in there are potential answers. And we can't list out every single one of them, so rather than listing them all out, we shade a whole area. Let's go back and remember some things about graphing lines. Remember that you use a dotted line when you have a less than or a greater than without an equal sign. And then you use a solid line when you have a less than equal to or greater than equal to. And so that's what we're talking about, graphing lines. And so that's when you're going to use the dotted versus the solid. Okay, how do you know which way to shade? And then also, what is the most common test point? There are two ways to shade these lines. One is if it's already in y is less than, then you would shade below it. Or if it's already in y is greater than, you would shade above it. Notice, we're talking about below and above. We are not talking about left and right. Because the y, if you think about it, the y-axis tells us the up and down values. So shading below or shading above. That's one way. But we know that they're not always in y equals mx plus b form. We have other forms. So if they're in a different form, or any form really, you can always test the point. Typically we use 0, 0. Not always. There are some exceptions. But usually 0, 0 is an easy one to plug in and do mentally. So we could plug in a 0, 0 into our equation, and then we'll see if it's true or false. And we'll do some examples like that so you can see what I'm talking about. All right, let's take a look at graphing some lines. This first line, before you just jump in and start graphing it, you need to take a look at, should I be making a dotted line or a solid line? Because it really stinks to go and make the whole line and then realize you've done the wrong kind of line. So y is less than 4x minus 2. That just means that we're going to start at negative 2. We're going to go up 4 and write 1 and so forth. And then we're going to draw our line. This time, when we draw our line, we need to make it a dotted line. That's what that less than equals to means. That less than means that. So that's what we're going to do. So I'm going to use my drawing tool. Oh, and it didn't make it dotted. I can make it dotted though. You should probably use a straight edge of some sort just to make sure that you've got a good line in there. But I am going to make mine dotted. So there's my dotted line. Now, I have to think about, should I go above or below? And once again, it's not left and right, it's above and below. So this is less than. If I think about my y-axis, less than means below. So if y is less than, that means everything down here is what I'm going to shade. And it doesn't have to be pretty, okay? Let's take a look at example number 2. This one is already in a different form, so we might consider doing something different with it. The first thing I'm going to do is make my table of values with my zeros using my cover-up method. So my y is going to be 6, my x is going to be, y is 6 and x is 8. This is a lot like the warm-up we had the other day, but we only have positives here. So x is 8. It's going to go off a little bit. 6, 7, 8. We'll call that 8 over there. And then 6, that one's going to go off a little bit too. Let's just call that one 6 right there. And now I do want to connect those this time. If I look over here and see, this is going to be solid, isn't it? So I'm okay with a solid line this time. Let me get my line tool. And so I'm going to connect these with a solid line. Now we have to talk about shading. So we're going to take a look and decide which way to shade this. Now, let me go ahead and talk about the test point. Most people, it's not their favorite way, but I want to make sure we understand it so that we see what we're doing. If I take the point 0, 0, and I plug it in, then I'm going to have 3 times 0 plus 4 times 0, and I'm going to see if that is less than or equal to 24. Okay, well, 0 plus 0 less than or equal to 24. Yes, 0, 0 is less than 24, 0 plus 0. So since I tested 0, 0, I want to come over to my 0, 0 place. Here it is. And it was yes. It was true. So if it's true, that means I am going to shade this way. So I'm going to go ahead and shade all of this area down here. Make sure I get everything in here that needs to be shaded. Now, that is plugging in the test point 0, 0. You need to know how to do that because there will come times when you need to do that. But let me go back and explain that logic again. What if instead we did the other method, which was just solving for y, like making the y by itself? Well, if I subtract 3x, then I get my y over there, and it doesn't even really matter what the numbers are. It's going to be less than, so its y is less than. That means below. So yes, I am shading below, which is what I had before. I'm just trying to confirm with you that's how to do it. So that is an example of shading a slope-intercept and shading a standard form. I think on your notes there is not this last example, but I want you to write it in here. So take a second to write this down. This equation, put that in there, and then write in what the slope and the point is. So again, we did a warm-up like this recently. Our slope, hopefully that's an easy one, that's a -1/2. And our point is -3, +5. So I'm going to go over to my line. I'm going to go to -3, +5. Pretty sure that's -3, +5. And then, is this going to be solid or dotted? Hopefully you can see that needs to be dotted. Oops, that's a dotted. Sorry. So from this point, I count my slope down 1, right 2, down 1, right 2, down 1, right 2, etc., etc. Or you could think of it as up 1, left 2, up 1, left 2. Okay, I'm going to go ahead and connect my points. I need to make it a dotted line. Since I have my fancy tool, I can go back and change that. So I'm going to change that to a dotted line. And then I need to decide which way to shade. So once again, as far as the less than, greater than, this would be a pretty easy switch that I could just add 5 to both sides. And then I have y is greater than. Greater than means above. I should be shading up here. I always like to test my point 0, 0. So let's just test it, partly because I like to do that, partly because you need a little bit of practice with it. If I plug in a 0, 0, it's going to be 0 minus 5 is greater than -1/2 of 0 plus 3. And I need to simplify this a little bit and see if it's true. -1/2 times 3 is -3/2. Is -5 greater than -3/2? No, it's not. So if you'll look over at the graph, here's my origin, you'll see the answer was no. That means don't shade the origin. And so I've done it correctly. Okay, so this is the correct graph, the correct shading, and the correct line. Let's go ahead and turn the page. Okay, some word problems. We all need a little bit of practice with word problems, so here we go. This problem over in the margin, I have that this is going to be a y equals mx plus b problem, and I'm going to show you how I know that. In word problems with y equals mx plus b, the m is basically your per. You go through the sentence and you read, where is the per? And I have to say, sometimes it's confusing because sometimes there's more than one per and you have to be able to distinguish. Then there's the B, which is the starting point. So let's read this question. You are saving money to go on spring break. You start with $45 in your savings account. Okay, starting point, that's my B. And you add $15 per week. That's my slope. How long will it take you to save at least $350? We have a variety of ways we can solve this. We can make a table. We can make an equation. We could make a graph. We can kind of do a guess and check kind of thing. So because we are now more advanced in our algebra, let's go ahead and make an equation. So if I start with y equals mx plus b, I've already said my m is 15 and my b is 45. How long will it take you to save at least $350? Well, that's my total. That's like my y. Okay, so I'm going to put my 350 over here. And I'm going to skip that sign for just a second and I'm going to come back to it. How long will it take you to save at least $350? So $350 is the minimum. Everything else should be greater than that. And I think we could add an equal to with it as well. So this is our equation. Now we could solve this equation. We could subtract 45 and then we could divide by 15. So this is 20.3 is less than or equal to x. So you need to think about, what does that x even mean? What is it supposed to stand for? Well, it was $15 per week, so weeks is actually my x. So this means that the number of weeks has to be at least 20.3 number of weeks. So at least 20.3 weeks. If you wanted to, you could say, well, really, it's $15 per week. Your parents probably aren't giving you money in the middle of the week. They wait till Sunday, or however you are saving your money, your job, or what have you. So you might say at least 20 weeks or 21 weeks. That's okay. If you want to say at least 21 weeks, that's okay too. Example number 2. You are selling cookie dough to raise money for the upcoming band trip. Chocolate chip cookie dough sells for $12 per tub, and peanut butter cookie dough sells for $10 per tub. Your goal is to raise at least $120. How many of each type of dough should you sell? Okay, this is what I call a two types word problem. We have two types of stuff. We have peanut butter and chocolate chip. And those A and B are the two types. So this is going to be our peanut butter and chocolate chip, whereas the C is the total. In this case, our goal is to raise at least $120. So that's our total, or our C. Okay, let's take a look. Chocolate chip cookie dough sells for $12 per tub. So we can say $12 of chocolate chip, and peanut butter sells for $10 per tub. Your goal is to raise at least $120. So you need to make more than $120, or equal to. So we didn't define our variables. We maybe should do that. That x would be the number of chocolate chip tubs. And excuse me, y would be the number of peanut butter tubs. Okay, looking at this equation, we need to graph this equation. All right, so we need to think about how we're going to graph it. It is in standard form, so if we come over here to the right, I think that the table of values with the zeros is going to be a pretty good way to do it. We're going to cover up that x, and we're going to take 120 divided by 10, which is 12. We're going to cover up the y and take 120 divided by 12, which is 10. This time on our graph, we already mentioned our variables. So our x variables is the number of chocolate chip tubs. And our y side, our y-axis, is the number of peanut butter tubs. And we can just count by ones. We'll make that 1, 2, 3, 4, etc. Oh, I'm going to run out of space, aren't I? That's okay. We'll just have to go off the graph. That's okay. Peanut butter, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so when I graph this, I'm going to have a point at 0, 12, which is going to have to be off my graph, and then a point at 10, 0, which is here. Is this going to be solid or dotted? It does have an equals with it, so it is going to be solid. We need to decide if we should shade above or below. Well, again, the y over here is greater than, so if the y is greater than, we're going to shade up here. And let's think about what that means. If we look at some individual points, like if we sold 2 chocolate chip and 4 peanut butter, is that enough? No, it doesn't get us there. If we sell 4 chocolate chip and 5 peanut butter, still not enough. If we sell something on the line like this is 4 chocolate chip and 7 peanut butter. My line is just a little bit off because it's not perfect there. But if we sold 4 chocolate chip and 7 peanut butter, it's on the line. If it's on the line, that means exactly $120. Any combination that's exactly on the line here means that it's going to be exactly $120. So we could sell 2 tubs of chocolate chip and, 9 tubs of peanut butter and make exactly $120. That also means anything out here is over $120. So any combination of these, we have exceeded our goal. We could sell 8 chocolate chip and 6 peanut butter. We would make more than $120. We could sell 7 chocolate chip and 9 peanut butter. That would be more than $120. So anything in this blue shaded area is more than $120. Anything down here is less than $120, doesn't qualify, that's why it's not shaded. And if it's on the line itself, it is exactly $120. Okay, that is what we need to know. But I do want you to write some things down in the summary. Some things you could write down is when is it solid and when is it dotted. Something else you could write down is when do you shade above and when do you shade below. Now, right now, I'm writing down suggestions. You need to be writing down full sentences. These are not full sentences. You need to write down full sentences of how you would do this. Another thing you could write down is when you do y equals mx plus b, what does the m stand for? What does the b stand for? Or when you do ax plus by equals c, what does the c stand for, etc. So those are some things that you can write down in your summary. That's it for today's lesson.